Auzubillahiminash-shaytanir-rajeem. Bismillahir-rahmanir-rahim. Assalamu alaikum everyone. In today's lecture we are going to discuss important chapter of physical pharmacy, and this topic is about distillation. Okay, so this is from a book of physical pharmacy, and this is the chapter number 6 from the physiochemical processes. So now before we are going to start our lecture, I request you to please subscribe to my channel, like my videos, and also press the bell icon to get the notification of all the videos which I have uploaded. Thank you very much for liking my videos and for subscribing my channel. So let's start the lecture. So first of all, we are going to define it what is the process of distillation. So if you are going to define the distillation, so you have to keep a concept in your mind that distillation is a separating technique. So in this separating technique, you are going to separate a compound. Okay, you can be purify it. Okay, you can remove the impurities from it, and you can also do also purify or separate it from the whole impure compound, and then you can separate your active compound. Okay, so actually how you are separating a compound in it. So distillation is actually a process in which the liquid is vaporized. First आप क्या करेंगे, you are doing the vaporization process, then you again recondense that liquid, then again back into your liquid, and you can collect it in a container. So this is the whole procedure of distillation. Now another definition of distillation can be that it is a separation of a constituent from a mixture. तो आपने क्या करना है, you are separating a impurity or your active compound from a mixture. For example, this is the mixture you have given. It composed of a lot of materials. Okay, but you want to separate only one compound from it. So now this mixture could be a solid, this mixture could be a liquid. So how you are going to separate a particular compound from the liquid? So therefore distillation is going to help you to separate these compounds. By what? First it is doing the vaporization. Okay, by vaporization all the useful compounds is going to be vaporized and your impurities are not going to vaporize. Okay, so then after vaporization you again condense it, and after condensation you again purify it, you again collect it in the form of liquid, and you get your pure form of the compound, which is your desired compound. So now we see what is the general apparatus and the general diagram. So as you can see in this diagram, this is the heating material in which you are going to heat your farming compound. This is the water bath, which is dialed with the number 14. Okay, so in the water bath you can be add up water, you can use sand bath in place of it. Okay, so there is no specification. Then this is the flask in which you add the liquid which you have to distillate, or which you have to compound the separate compound into it. Then there is a flask, and this is the thermometer which attached to it. This is the condenser. This is the portion where you water inlet and for the water outlet. And the one main concept you have to remember in this uh, line, or in this paragraph, is that here the water movement is from this. Okay, from upper part to lower part. But if you see in the condenser, in this condenser, when there is a water movement is reverse of, is opposite to this water, the water is flowing like that. Okay, so at the sixth position you are going to inlet your water, and this water is going to at the opposite flow of your distillate, and then from here, from 7 number, this is coming out. Okay, so actually this is the water inlet and this is the water outlet, and water is moving at the opposite direction of your distillate. Then this distillate and move into your final, this is the your receiving flask, and again your receiving flask has a water bath. Okay, this is not specific that the every compound or every receiving flask has a water bath. And this yellowed liquid, this is the pure liquid, and it is called as distillate. T-L-A-T. Okay, so sorry for the bad writing, so you can correct it. Okay, so this was the apparatus of this process. You have to need energy source, heat source, still pot, still head. You need thermometer to measure the temperature. You need condenser. You need receiving flask or this distillate. You need vacuum pump, receiver, heat controller, stirrer. You need or heating material. You need a cooling bath. So all these things are really needed. And approximately measure this is a cooling bath. Okay, which cools your distillate. Okay. Now some kind of explanation is given in this paragraph, so now discuss that. So first of all, in the distillation process you are going to separate the liquid, and this liquid is going to be separated from non volatile impurities. So you have to make this concept, if your impurities are going to volatile, so what will happen, your distillate is again become impure. So you have to pure it, and you will pure it by what, by making and involatile impurities. So the separation of liquid from one to another, which with may be miscible, is partially miscible or immiscible. So process of vaporization in one vessel and condensing in the other vessel into the vapor. So this is called as distillation. And now there is a definition of distillation flasks, in which the distillation process is going to occur. So liquid which is being distilled or heated in a flask, उस flask को हम क्या कह रहे हैं, distillation flask कह रहे हैं. The vapors are condensed or cooled on a surface. This is called as water cooler condenser. So this is the water cooler condenser. And the resulting liquid which is going to receive your distillate, it is called as receiving flask. This is a receiving, this is yellow color, this is the your receiving flask. And the boiling point of the mixture depend upon the molar fraction of the compound. For example, if the pure substance, then the temperature remain constant. Okay. If the immiscible substance which can soluble in your liquid mixture, then the temperature increase throughout this process. Okay. Now we have discussed some there are some types of distillation. For example, steam simple distillation, fractional distillation, steam distillation, vacuum distillation, and destructive distillation. So these are very important and useful types of the distillation. So now we discuss them. We also discuss their whole procedure, their apparatus, and we also discuss their principle. And at the last we will discuss are the advantages of this type, and what are the disadvantages of it. So now let's start the first type, which is about the simple distillation. So as the word indicate that it is not going to be complex, it is just simple like. So it is a process of converting a liquid into the vapors by transferring vapors from one place to another and recovering liquid from the condenser. Okay. So it just consists of three parts, and the diagram of it you can see here. Okay. So here what is you are going to see, this is the flask, or this is consist of liquid or solution. This is the impure solution. Okay. Now this is the thermometer. Now when you heat it, it become vaporized, and these vapors become a flow in this condenser, and after moving from the condenser they will collect in the receiving flask, and in this receiving flask you will get your pure liquid. Okay. You will get it. So now we see how is the procedure for it. So the simple it apparatus consists of three parts. Okay. तीन parts हैं इसके apparatus के, और वो कौन कौन से तीन parts हैं वो भी हम लोग देख सकते हैं यहाँ पर कि still एक it consists of a flask which in which volatile material is to be placed. Second, it is consist of condenser, then it is consist of receiving flask. Okay. So now in simple distillation, just the difference is that you are going to separate compound on the base of different boiling point. So for the simple distillation you have to take the compound which have different boiling points. Okay. So आपने क्या करना है, you have to separate a compound from its impurity. So you must keep the thing in your mind that the compound, your active compound which you want to be separate out, and your impurity, both of them have same different boiling points. Okay. This is for the different boiling point, not the same boiling point. If they have a different boiling point, then this simple distillation can be occur. If they don't have if they have same boiling point, then you cannot undergo the process of simple distillation. Okay. So the process is generally used to separate a non-volatile solid. Okay. Your non-volatile impurities, for example the preparation of distillation water, and you can recover alcohol from it. Okay. So you must have to heat the compound at its boiling point. So as you can see here in the diagram. So this liquid has some boiling point. You have to find that what is the boiling point of it. Okay, consider it has the boiling point of 70 degree. So you have to provide the heat to this liquid at the 70 degree, but you make sure that the impurities which is present in that liquid, or consider that we have two liquids and we have to separate them. One liquid has 70 degree boiling point, while the other liquid has 50-degree boiling point. So what you will have to do, if consider your desired compound is the compound which have boiling point 50. So when you heat at, and when the temperature reaches at the 50 degree, then the liquid vaporize, and then move to the condenser, while the liquid which have 70-degree boiling point will remain in this flask as a impurity. So this, in this method, we are going to separate the compounds by the simple distillation. Okay, so this was the simple uh, uh, of principle of this compound. So there's another term which is called a double distillation, as the word indicate that you are repeating the process of distillation. So the repeating process of distillation will going to help us to purify, to more purify your compound. Okay, so it increase, enhance the impurity of your compounds. Okay, so there will be no impurity will be left out. Now what is the procedure? So first, you have to laboratory scale and a distillation flask with a stopping a downward use. Temperature is used to find is used to be measured by the use of thermometer, and then thermometer is inserted with the help of cork. And the size of flask should be good enough to keep all the liquid in it. Then you have to heat it, and then the vapors is going to be formed, and these vapors will pass out through the your condenser, and then they condense. So what is your condenser? The definition of condenser is written here, that it is a heat exchanger which kept a cold your distillate by the steam of cold water. So what are the properties of this condenser? So it should be easily clean. Okay, it should be easily replaceable in case of broken down. It should give the maximum cooling surface, and it should be a good conductor. It should be less conductor. It should flow the water into your opposite direction. So these are should be the properties of your condenser, that easy flow ho, there should be a replaceable ho, it should have maximum surface area for the cooling, and the water flowing in this condenser should be in the opposite direction. So what are the limitations? You know, every process have some disadvantages and advantages in it. So the limitation in the simple distillation is that you have to give maximum amount of boiling point, which is the 70 degree. And you know that this is very simple, and sometimes impure substance will remain in it. So this is the some limitations of your simple distillation. If you see the properties, so this is very simple, fast process, consume less energy. So this is the advantages, but it has poor separation, because sometimes of some impurity will remain in it, and best for the relative pure liquids. Okay, and now some applications of it is given, that it is used for the purification of various liquids, and it is used for the separation of liquid from non volatile solids. Then it is also used for the separation of different substances, separation of distillation water, and also used for the identification of various organic compounds. Now after discussing the simple process of steam simple distillation, now we are going to discuss the fractional distillation. Okay, so in the fractional distillation, it is just like the simple distillation but has some differences in it. So in the fractional distillation, you are going to separate two liquids. Okay, so in the simple distillation process, you have separate a liquid from non volatile solid, but in case of fractional distillation, you can separate a liquid from another liquid. Okay, but the one thing you have to get, both of these liquid can have near or closer boiling point. For example, if one liquid has uh, for example a 75-degree boiling point, then the other could have a 73-degree boiling point. Okay, so this can be happened because they have very closer boiling point, but the fractional distillation provide you the advantage to separate them, whether they have same or nearly same boiling points. So now let's see how it is doing work, especially to separate the miscible volatile liquids having different boiling points, for example mixture of alcohol and water. So alcohol and water has nearly and same boiling point, so they can be separate out. Now it is quite easy to separate them, because fractional distillation is going to introduce another apparatus into it. Okay, so due to the addition of another apparatus, this would be very easy for us. Now let's see how it is quite easy method. So it is quite easy method to separate the liquid from non-volatile solid by the simple distillation, but it is but is very difficult for the simple distillation to separate out two liquids, okay, of having very same boiling point. So for having same boiling point, we are using fractional distillation, and we use same condensation cycles, and just as addition of so just it has addition of apparatus which is called as fractional column. Okay, so what you are adding, you are adding a fractional column, and fractional column structure is like that, as you can see here. This is the fractional column. Okay, so all the apparatus which you use in the simple distillation is same, just there is a difference of fractional column. When you insert the fractional column, it will become fractional distillation apparatus. So, what is the role of this fractional column between your distillation flask and your distillation head? So, fractionation comes separate the subject to many condensation cycle as the material move toward the distillation head, with each cycle within the column and composition of vapors progressively enrich. सो ये यहाँ पर ये कहना चाह रहे हैं कि जब आप फ्रेशनेशन कॉलम डालते हैं तो इसके अंदर काफ़ी सारे कंडेंसेशन के साइकिल्स होते हैं। कैसे साइकिल्स होते हैं आप यहाँ देख सकते हैं, फ्रैक्शनल डिस्टिलेशन का कॉलम का ये देख सकते हैं। तो यहाँ पर जब वेपराइज होता है तो यहाँ वेपराइज होने के साथ ही यहाँ पर उसकी कंडेंसेशन भी हो जाती है, फिर दोबारा ऊपर जाएगा, दोबारा वेपराइजेशन भी हो रही है, कंडेंसेशन भी हो रही है, फिर और ऊपर जाएगा, वेपराइजेशन भी हो रही है, कंडेंसेशन भी हो रही है। तो इस वाले कॉलम में उसके साथ यही कुछ होता रहेगा कि बहुत सारे साइकिल्स रिपीट होते रहेंगे। फ्रैक्शनेशन कॉलम में कंडेंसिंग का एक प्रोसीजर जो है वो लगा हुआ होता है, जिसकी वजह से ये ईजी हो जाता है लिक्विड का बार बार कंडेंसेशन और वेपराइजेशन के केस से गुजरना। सो अब हम इसका प्रोसीजर देख लेते हैं कि वो क्या चीज़ आ जाती है इसके अंदर। So distillation is the one of the oldest and still most common method for both purification and identification, and it is physical process to separate out your chemicals. Some people think that it is a chemical reaction method, but it's not a chemical reaction. It is a separating technique and a physical separating technique. Nothing is going to be changing your chemical properties. Okay, the chemical properties of all the liquids become same. Just this is a separating technique. It is used for the purification of your particular compound. So as the mixture is heated and the temperature is rises and reaches the temperature of lowest boiling point in the mixture, while the other compound mixture remains in the original phase in the mixture. So what you have to do, you have to boil it, and the compound having lower boiling point will vaporize first, and the which have a high boiling point will remain the same. Now we see the principle. So principle of based on the explanation of large number of theoretical vaporization and condensation cycles. So vaporization and condensation cycles, this is the principle of your this fractional distillation. So the apparatus for the simple distillation is just modified by inserting the fractionation column between your distillation flask and your distillation head. So fractionation column, this column is begin inserted between the distillation head. This is the distillation head in which you are inserted the thermometer, and this is the distillation flask. So between the distillation flask and distillation head, there is the fractionation column. So fractionation column provide large surface area to initiate, distillate and redistillate and condense it again. So you can provide correct, it is providing what, large surface area to condensate, to recondensate, as well as to condensate again and again. So the process continue as the vapor rise up the columns. The vapors finally make into the condenser, and then they go into your final recondensing receiving flask. Okay, so now we see what are the properties of fractional distillation. So it is a complicated process, but it is a slow process and consume more amount of energy, but it provide better separation, or can separate the compounds having close a boiling point. So this is the advantage, and this is the disadvantage of this compound, this process. Now the application is again written here, that is used to separation of two immiscible liquids. That is very important. These liquids should not be soluble into each other, and they have different boiling points. And it is also used for the manufacturing of alcohol. So we have discussed the two types of distillation. Now we are going to discuss the third type of distillation, which is called as what? Steam distillation. It is quite similar to the both above distillation, but as the name indicates, there is some modification. And what is this modification? Let's see it. First we discuss the introduction. So the simple distillation is a type of distillation for the temperature sensitive material. So as you see, we have a various compound which are temperature sensitive, and the most temperature sensitive material are like aromatic compounds. So your aromatic compounds can undergo the decomposition due to the high temperature. So we if we want to purify a thermal and stable compounds, so we should use the process of steam distillation. So many organic compounds can lead to decompose at the high temperature. By adding water or steam, the boiling point of compound are depressed, and then we allow them to evaporate at the low temperature. So now here you can understand from this diagram. So this diagram is a little bit different from the upper two diagrams. So now what you have to do, you have to take your desired compound or the compound which is impure at this position which I have circled it. Now what you have to do, you have to heat this bottle which is full of water. You have to vaporize this water. This is pure simple water, not your liquid. Okay, so first the vapors of these will rise up and they go down and they go enter into the flask which contain your impure liquid. So by giving the steam, you are heating your this impure liquid. Okay, and so in this way you not directly heat this thermal unstable compound. You just provide the steam, and by the steam heat, this compound will reach to its boiling point. When it's reached the boiling point, it again vaporize and move to the condenser, and from condenser it will condense, and the final product will be obtained. So this was the actually procedure or the principle of this uh, process. So first we discuss the principle of this process. So, the method is basically on the fact that the total vapor pressure above the mixture of two immiscible. So now you again taking the two immiscible, and the vapor pressure sum is equal to the independent liquids. So a liquid at the temperature when it's vaporized become equal to the atmospheric pressure, then it is going to be boiled, and steam is continuously passed through your impure organic liquid, and the steam get heat and recondense your into water again. The resulting mixture of a liquid and the water begins to boil, and then the vapors from the mixture become equal to atmospheric pressure, and then they vaporize again. The mixture of two immiscible liquid will boil at the temperature lower than the normal, and the mixture will continue to boil at the same temperature, and distillate will contain the water as well as liquid, separates out into the two liquids because they are immiscible. So as you see here, so from here the water vapors as well as the liquid vapors, both of them move through the condenser. So there is a possibility that this distillate fluid contain water in it, but you see distillation flask contain a solute or a compound which is immiscible with the liquid. So that we get the two layers of the liquid. One is the pure liquid which we want to take out, and one is the water. So both are immiscible in each other, they will form the layers, and then we can easily separate out both of these layers. Okay, so this was the principle of it, and now we see how the small scale steam distillation can be carried out. So what you have to do, you have to take your apparatus, you have to take the steam generator. So this whole procedure, this is the steam generator. It fixed with the rubber band through the hose. You have to safely band the rubber hose. Now you have to heat your water vapors, heat water, and its water vapors is going to produce inside the generator. Now the second hole of the tube is bent out, and this steam is to be carried out into the flask, a distillate flask. Okay, then it will be, so whole the process which I have explained to you, whole process is discussed here, so I think it doesn't need to be repeated. Now at the last you will discuss the application of this compound, that distillation of water immiscible liquid at very high boiling point can be carried out, and it is also used for the crude drugs. Okay, to separation of the crude drugs, for the separation of volatile substances, and it also used for the separation of thermal unstable compounds such as aromatic compounds or other organic compounds. So it also used for the synthesis of complex organic compounds. Now, the fourth type of distillation is the vacuum distillation. As its name indicates, now you are going to what? Introduce a vacuum pump into it. Now, the purpose for the introducing the vacuum pump is to reduce the pressure. So now you are performing your distillation under the reduced process pressure. So there is a beneficial of it, because whenever you are decreasing the pressure of a compound, then by reducing pressure, its boiling point also decreases. Mean, if a compound boil at the 70 degree, then after when you decrease its pressure, its boiling points decreases to 60 degree. So it is very useful for us, because it is useful and it is easy to attain the temperature of 60 degree than to attain the temperature of 70 degree. So in that method, this vacuum distillation is going to help us in this process. So what it is working on the principle that the liquid boil when the vapor pressure is equal to atmospheric pressure. This technique is used for the purify and separating thermal unstable liquids compound that decompose at their normal boiling point. So this is used for the liquids which are such unstable that they can decompose on its own boiling point. So you have to decrease their boiling point to get purification. Okay, so how you will decrease their boiling point? By reducing pressure. So what you are to do, you under the reduced pressure, this is less height of less chances of decomposition. So the boiling under the reduced pressure also increases the rate of distillation. So it is very useful. If the rate of distillation increases, you will give the fast procedure, not as and you will also consume less amount of energy, less amount of fuel for producing the heat. Okay, so this is the beneficial of this process. Now we discuss what is the principle of this process. So first you have to lower your pressure on the surface of liquid, and after lowering this, then you have to distillate or boil it, and the compound will never undergo the decomposition, because it is going to be, the temperature is going to be lower than your boiling point. So and the distillation will be carried out at the fast rate, and the apparatus used for this process is the casein flask. Okay, so as the scientist Calcine proposed this apparatus, so for this name, this procedure is named at. So first you can see here in the diagram, this is the manometer, this is the vacuum pump, and what is going to happen, this is your distillate fitting with the capillary, and the boiling capillary is to provide the regulation of air. Then you have to move, this is the thermometer, this is the condenser, and this is the pure liquid which is obtained under the reduced pressure. So manometer is used for the detection of what is the measurement of pressure. So by inserting manometer, you can calculate what is the pressure of a compound at this point. Now let's discuss the process of it. So distillation, the reduced pressure is very common. Distillation flask is most commonly carried out, especially design flask which is called as calcine flask. Especially if this flask consists of two necks. Okay, दो neck हैं. As you can see here in the diagram, it has these two necks. Okay, so through one neck, a thermometer is going to insert it and attach to the condenser, and the second neck is consists of very fine capillary tube is inserted into it, which completely dips into the boiling liquid. As you can see here, this is the screw, and this is the capillary tube, and this is the thermometer. Now the bumping is already during the distillation. The reduced process can easily prevented by introducing the steam air by passing through the liquid to the capillary tube. Now capillary tube should be sufficiently or permanently to slow the steam or bubble to blow out into the tube. Now the side of tube receiver is connected to the vacuum pump. So all the vacuum distillation has small pressure gas which is called as manometer. Okay, so the insertion of manometer in this vacuum distillation is very useful. So you should insert it between the receiver and the between the vacuum pump. So you so here there is a mistake in the diagram, because in the reading and they say that your manometer should be at this place. Okay, should be at this place between the receiving glass and between the vacuum pump, but it is drawn behind it. But you have to keep this point in your mind. Okay, now in carrying out the distillation, heating is not considered until the required vacuum is going to be obtained. Now, heat the flask should be done on the water bath at the temperature of 20 degree. Now, the thin glass apparatus should be ordinarily flat bottom, and conical flask should be used. In some cases, preservant forming can form during the vacuum distillation. You have to prevent it by adding alcohol. So some advantages of vacuum distillation are given that the compound which can decompose on liquid can be purified by the use of vacuum distillation under the reduced pressure under their low boiling point. So distillation under the reduced pressure consume less fuel, so this will be very economical for us and very cheap for us. Vacuum distillation is also safety recovered, and it is also use solvents for the boiling point under the 100 Fahrenheit, and distillation should not be used on the solvent with boiling point below 200 Fahrenheit. So applications is that it is for the thermoliable substances which are thermally unstable. Second is that for the concentration and drying of extraction will destroy at the high temperature, so therefore it also used for the purification of vitamins. So these are some advantages of this vacuum distillation. Last type is the destructive distillation, and it is very shortly explained that destructive distillation term is used to describe the decomposition of a substance, usually a natural product, by heating and by condensation and collection of volatile compounds of the decomposition. So it is not pharmaceutical process, but is used in the pharmaceutical manufacture of some substances and in some medicines. So therefore because it is not using in the pharmacy, so we don't discuss it in the detail. So now the processes or the types of distillation which use widely in the pharmacy are discussed. So I hope that you will understand this video lecture. If you have some confusion about this lecture, so you can ask me on you can ask questions in the comment section. I will answer to you. Thank you so much again for watching this video, and please like my video, subscribe to my channel, and also join with me and become the my YouTube family. So मिलेंगे अगले लेक्चर में, तब तक के लिए अल्लाह हाफिज़.